Okay, good afternoon, everyone. Right. Okay, so today I will teach about free fall. Okay, free fall. Okay, let's wait like 1-2 minutes for your friends to join. Teacher, when we get the notes and tutorial? Okay. Um, I think today, but I'm not sure at what time because I asked the shop to send directly to the guide post. Okay, so I will ask the shop first when he will send the tutorial. Okay, so I will let you know. Okay, so we continue, right? Free fall. Okay, so I think you already heard this story before. Okay, this is a famous story, right? So how does the Newton discovered the gravitational force? Okay, so when he sit under the tree, right, the apple tree, okay, and then suddenly he saw the apple fall down, okay. So he think must be something, right, that makes the uh, apple fall to the ground. Okay, so there must be a force, right, that attract the apple to the ground. Okay, so then he's investigate. Okay, he do the experiment. Okay, and then he discovered the gravitational force, right? So this is the famous story that I think most of you already know. Okay, so an object experience a free fall. Okay, so a free fall if the motion of the object is affected only by the gravitational force. Okay, but usually, okay, in our daily life, okay, if the mass of two objects is quite different. They say the first mass is 1 kg and then another mass is 6 kg, right? So I'm sure that you already know, of course, the mass for 6 kg it will arrive first, right? Because of the air resistance. Okay, but that is in daily life. Okay, so but let's say the mass between the difference between the two mass is not so different, they can fall in the same time, right? Okay, so an object experiences a free fall if the motion of the object is affected only by a gravitational force. Okay, so this implies a free falling object does not experience the action of other force such as air resistance or friction. Okay, so this one I think you already learned yesterday. Okay, so free fall is only affected by the gravitational force. Okay, so a coconut falling from a coconut tree. So is this a free fall motion? Yes, right? Because it's only influenced by the gravitational force. So let's say in the exam, they ask you what does it mean by the free fall. So when object is fall under the influence of gravitational force only. So that will be the answer. Okay, so acceleration due to gravity. Okay, so the object falls because it pulls towards the earth by gravitational force. Okay, and then the pull of gravity causes an object to fall with acceleration. Alright, so the acceleration due to a gravity g is the acceleration of an object due to the pull of the gravitational force. Okay, so how actually the acceleration of the object is influenced, okay, by the gravitational force. So what is the standard value of the acceleration? So there's the value is 9.81. Okay, this one, the value you must remember, right? 9.81. Because before this, for KVSM, we use 10. 10 ms negative 2. Okay, but for KSSM, they changed to 9.81. So whenever you need to substitute the value of G, so you have to use 9.81 ms negative 2. Okay. Alright, so the velocity of a free falling object increased by 9.81 meter per second. So actually 9.81 ms over s, right? Okay, so means for every 1 second, the velocity will increase 9.81. Okay, so let's say for 1 second, it's 9.81, and then when 2 seconds, so 9.81 plus 9.81, you will get 17.62 ms negative 1. Okay, then it keep increase 9.81 for every second. So that's the meaning of the 9.81 ms negative 2. So means for every 1 second, it will increase the velocity about 9.81. Okay. Okay. Alright. So this is to investigate the motion of falling object. Okay. So there are two ways. Okay. The first one, this one, they use a stroboscope. Okay. So some of you wonder what is a stroboscope, right? And then this one, the second one, they use a ticker tape. Okay, that one I think you already know, we already learned for 2.1, right? 2.1, okay. Uh, how to get the ticker tape, okay, how you want to use the ticker tape, okay, I already show you the video. Okay, but this one they use a stroboscope. Okay, they use a stroboscope, okay, and then they put the ball, okay, for a certain height, and then they release the ball. So you can see the ball will be like this in this motion. Okay, and this one they will attach the ticker tape to the object that fall. Okay, and then you can get this. Okay, like this. Okay, so we see the video first. Okay, how about the stroboscope? How you can get this motion? Okay, wait. Hmm. All right. Okay. Okay, this is the stroboscope. Okay, so this is the stroboscope. Okay, so what is the function of the stroboscope actually? So a stroboscope is actually to freeze the motion. Okay, to freeze the motion. So later you will see how does the freeze the motion of the ball. Okay, so this is called as a stroboscope. Okay, so when first how you want to use it, you will set up the frequency for the stroboscope. Okay, so if you increase the frequency, okay, the ball will fall more, will fall slower. Okay, so let's see. Okay, I will just fast forward the move. Okay, so this is the stroboscope. So, alright. Okay, so the ball. Okay, right. So that's how it captures the image, right? And then this is the final image. Right. See, right? You can see, right? This is like a ticker tape also, right? It can produce the dots, dots, dots like that. Okay, but this is actually the ball. Okay, so this is the function of the stroboscope. So mean after that you can take a ruler, okay, and then you can measure the distance and you can calculate the acceleration, right? By using the ticker tape before, we use the A equals to B minus U divided by T, right? And then you have to find T, what is a B, right? And then you can just use the ruler. Let's say this is U, this part is U, and then this part is B, right? Okay, and then you can use U S is equals to T, sorry, S divided by T, and then the T you can find by the finding the frequency. Because it's already give you the frequency here, because you have to set up the frequency first, right? So you already know the frequency. And you already know the formula for frequency is F is equals to 1 over T. Okay, so now you already have T. Okay, right? So then you can calculate by just same way as you calculate the acceleration for the ticker tape. Okay, So can you understand? So this is the function of the stroboscope. In our lab, there's a stroboscope, but I'm not sure whether it can be used or not. Okay, because I think it's very long time we didn't use the stroboscope. Okay, so I'm not sure whether it still can function or not. Okay, so anyone want to ask anything about the stroboscope? Okay, so this is same as like this one, right? Wait, I will stop share first. Okay, right? This is same like this, right? If you compare, right, here, right, here, and also here, right, is same. Okay, so then you just can calculate and then I can plot a graph. Okay, so we have to measure like 1 second how many, right? So this is how they use a stroboscope and how they produce the motion like this. Okay, so and then this one you already know they use a ticker timer. Okay, and they just attach to the object that we fall into the ground that will give you reading like this. Okay, so anything you want to ask teacher? Can you understand before I move on? Yes. Mm-hmm. Can. All right. Okay. So now we already have the reading. So let's say you do the experiment. So you got like this. Okay. So the first one, okay, the first one is said F2, describe the velocity of the ball. Okay. So here you already know V is equals to, sorry, V is equals to S over T, right? And you can see here the distance, okay, between the two balls is increasing. So means the S is increasing. So that's why the position of the ball increase. Okay. And then when the S increase, okay, the V also will be increased. Okay. So the velocity also will be increased. Okay. So that is the answer for question 1A. Okay. And then how about 1B? Okay, how about 1B? Okay, what can we deduce from the gradient of the V against T graph? Okay, so here we already learned before, right? When you learn the chapter 2.1, right? The gradient of the velocity against time is actually equals to what? The gradient of velocity against time actually equals to what? Acceleration, yes. Okay. Displacement is area under the graph, Sajid. Area under the graph for velocity against time is equals to displacement. Okay, but for the gradient is equals to acceleration. Okay. So what can we deduce from the gradient of the V against T graph is actually the acceleration. Okay. So remember when I say if you want to find the gradient, you have to draw the triangle, right? So let's say this is the graph. Okay. So when you draw the triangle here, okay, when you draw a triangle here, the size of the triangle is same, right? So means the gradient is same. So when the gradient is same, gradient is equals to acceleration, right? So means the graph is move with the uniform acceleration. So when you describe the motion of the ball, should be, okay, uniform acceleration or constant acceleration. Okay. So this is the answer for the B and C question. Okay, so what can we deduce from the gradient of the V against T graph? So you can see I draw the triangle size of triangle is same, means the gradient also same. So gradient is actually the acceleration, so the acceleration also will be same. Okay, and then describe the motion of the ball. So it also move with the constant acceleration. Okay, so now we can deduce that constant acceleration. So what is actually the acceleration here? The value of acceleration is 9.81 ms negative 2. Okay, so that is the acceleration. Okay, alright, so Galileo performed the experiment in the Leaning Tower of Pisa. Okay, so he found that the two iron balls fell down at the same time. Okay, So now let's say we hold two stones, okay, with different size at the same height, and then drop both stones simultaneously from the same height. Okay, so describe how the velocity changes. Okay, can you try to answer this one first? How the velocity change? Okay, both has a two stone, okay, different size. So how does the velocity change? Whether it's increase, decrease, or uniform? And have to compare the time. Okay, so I recall 3% to answer. Let's try with Yumin. Lim Yumin. Okay, Lim Yumin. So how to describe the velocity changes? Okay, we know that this one it will falls under the influence of gravitational force, right? It means gravitational acceleration. Okay, so when the gravitational acceleration means the acceleration is always same, right? 9.81. So the graph should be like this. Okay, but then how about the velocity? Lim Yumin, are you here? Okay, so what's the answer? What is the velocity? How does the velocity change? This is graph for acceleration against time. So what if for velocity against time? Increase, decrease, or constant? Lim Yuming? Yes, what's the answer? Decrease. So the velocity will be decreased. Alright. So here, let's see the graph here. Okay. So the graph here is the when the object falls down, right? Okay. So mean it will release. So the object will move downward. So when the object moves downward, the velocity will be increased, right? Velocity will be increased. Okay. But if you throw the ball upward, that one the velocity will be decreased. Okay, but this one the ball moved downward, so means the acceleration is same, right? Acceleration should be same, okay, should be constant, that is 9.81. So you already learned the graph right before. If the graph is like this, okay, if the graph, the acceleration is like this, means the velocity is increasing, right? So let's say if I draw the graph, okay, if I draw the triangle, the gradient should be same, and the graph of velocity against time, the gradient is equals to the acceleration. You can see the size of the triangle is same, means the gradient is same. So gradient is same means acceleration also should be same. Okay, so the answer should be increase. So velocity increase. Okay, yes. Okay, and then you have to compare the time taken for the stones to reach the floor. Okay, so how about the time taken? Is it same or is it different, or maybe the stone, the smallest size of stone reach first, or maybe the big size of the stone of the stone will reach first the ground? Which one? How about the time taken? Anyone want to try? How about the time taken? Yes, should be same because it's only fall under the gravitational acceleration. Okay, so means gravitational acceleration means it's falls under the gravitational force only. Okay, so when it falls under the gravitational force only, so mean it will reach on the same time. Okay, so is the acceleration of the stone influenced by their mass? No. Okay, it's not influenced by the mass. Okay, right, so we have a one video here. Okay, so this is to show that object that have a different mass. Okay, we reach the floor at the same time. Okay, so let's watch first. You can see it reach at the same time. Okay, but it has a different mass. Okay, so let's see again. See, it reach at the same time. Okay, even it's a different mass. So this show that the mass does not influence the gravitational acceleration. Okay, all right. Can you see the video clearly?
Really? Yes, sir.
All right. Okay, the next one is okay, like okay, let's try to answer this question first. Okay, 1A until 1D. Okay, this one they use a golf ball and the paper. Okay, and then the next part they use a golf ball and have to use the crumpled paper. Okay, so for the first one, 1A, for the you have to hold a golf ball and a piece of paper at the same height and drop them simultaneously. Okay, so then they ask you which object reach the floor first. Okay, so this one is actually the surface area. Okay, this one is actually the difference is the surface area. Whether the surface area will influence the gravitational acceleration. Okay, and then this one, the golf ball with the crumpled paper, and then you have to explain whether it will reach at the same time. Okay, or maybe the golf ball uh, arrive first because of the mass. Okay, okay, for 1A. For 1A, Mickey Leong Mi Yi. I'm sorry because is it correct your name? Mickey, I just call you Mickey, is it okay? Alright, Mickey, can you give me answer for 1A? Okay. So this one they have a golf ball and also a piece of paper. So which object will reach first? Mickey? Are you here, Mickey? Mickey, are you here? Yes. So which object reached the floor first? The golf ball or the paper? The golf ball. Okay, right, correct. The golf ball. Okay, this is right. Okay, next one. I want you to explain to me why. Okay, Sharanya. Sharanya. So can you explain to me why the golf ball reached the floor first? Sharanya, are you here? Yes. Okay. Why? Why the golf ball arrived first? What is the difference between the golf ball and the paper here? What is the difference? And we already know the mass does not influence the gravitational force. Okay, it's not influenced. Okay. So why the paper does not reach the floor first? Why must be the golf? What is the difference between the golf ball and the paper? Small surface area. Okay, so when small surface area, that means the air resistance is lower. Okay, if the large surface area, okay, so large surface area means the have the higher air resistance. Okay, and if the small surface area, okay, will be have the lower air resistance. Okay, so this one is actually is influenced by the air resistance. Okay, okay. So the surface area of the paper is big. Okay, so that's why the has a high air resistance. Okay, so that's why the golf ball arrived first because of the surface of the area. Okay, and then next one for C. Okay, I will call another one. Another person that is Yap Junhin. Yap Junhin. Are you here? Yes. Okay, so repeat with the golf ball and a piece of paper which is crumpled. So which object reached the floor first? Same. Okay, is it correct? Yes, same. Right? Because of the surface area is same. Right? So means that air resistance that acted on the both object also should be same. So they will be arrived in the same time. Okay. So the surface area of the crumpled paper is also smaller air resistant. Okay, so now it's like the same as a cloth paper, right? So it's almost the same, their air resistance. Okay, so compared for the first one, the paper, they have a large surface area. So this one has a high air resistance. And this one, where the crumpled paper, this one, the surface will be lower. So mean the air resistance will be lower. And then the same, the area, the surface area for the golf ball and also for the crumpled paper is almost the same. So means the air resistance that acted to the both object is actually same. So that's why they can arrive at the same time, right? Okay, so let's see a video. Okay, to show that it's really when the golf ball and the crumpled paper, okay, that falls to the ground, it will reach at the same time. Okay. Right. See, they reach at the same time, right? Okay, for number two. Okay, a coin and a feather are released from the same height simultaneously in the laboratory. Okay, so the observation, okay, what is the observation here? So when you release at the same height, okay, in the lab, okay, you can see here the coin that will the force that acted to the coin is the gravitational force, and also air resistance that add to the coin. Okay, and then this one also gravitational force and also air resistance. Okay, but this one, if we compare the surface area, of course the feather has the largest surface area compared to the air resistance, so that's why this one air resistance is much higher. Okay, and then the feather, what we can observe, the feathers fall slower than the coin. Okay, so this one you have to label two force that acted on the coin. The first one is the gravitational force. The second one is the air resistance. So remember, the air resistance, the direction must be always opposed the gravitational force. It seems like the friction force, right? So friction force also, let's say if you move your object to the right, okay, the frictional force should be in the left. So this one also same. Okay, so for the gravitational force, it moves downward, so the air resistance will move upward. Okay, it will always oppose the gravitational force. Okay, so this one, they have a difference in the surface area. This one has a higher surface area compared to the coin. So of course the feather will fall slower than the coin. Okay, so what is the explanation? So this one is involve the surface area. So remember, when you explain about this one, you don't explain about the mass, right? The mass is actually does not influence the gravitational force. The only thing that influence the gravitational force is actually the size of the surface area. Okay, so the surface area of the feather is bigger, so means there has a high air resistance. Okay, so alright, so in daily life, why we see that the heavy object fall and reach the ground faster than light object? Okay, this is due to the air resistance. Okay, okay, so let's say we do this in the vacuum. Okay, so vacuum means no air. No air means no resistance. No air resistance. So whether doesn't matter what is the surface area of the object, they will fall at the same time. They will reach the floor. They will reach the base at the same time. Okay. So what we can observe here, so we can say that the feather and the coin reach the bottom at the same time, because no air means no resistance. No air resistance. Okay. So the explanation is, in vacuum there is no air resistance. Okay, so the only forces acted on both objects is the force of gravity. So means the acceleration is 9.81. Okay, and the both object reach the bottom with the same acceleration due to gravity. So means the only thing that influence the object to fall down is only the gravitational force, and it will move at the same acceleration, that is 9.81 ms negative 2. Okay. Okay, in what of condition object at different masses fall with the same acceleration? Okay, when you have a free fall in vacuum. Okay, when you have a free fall in vacuum. Okay, even that this one they have a larger surface area, this one has smaller surface area. Okay, but there is no air, right? So mean no air means not air resistant. So mean when they fall, they will reach at the bottom at the same time. Okay. All right. Okay, so I think this one you already saw the video yesterday, so I think I will not show it again. Okay. All right, and then the next part, okay, so this one is actually, they said the value of the G is different, okay, from another place to another place. Okay, so why? Okay, they say here, okay, here at the North Pole is 9.83, okay, but here at the center here is 9.78. Why? Because it's actually our Earth is not a perfect sphere. Okay, it's not a perfect sphere. So that's why, okay, let's say for this one, the distance between the center of the earth is bigger than this one. So that's why this one has the higher gravitational acceleration compared to this one, right? Because this one, the distance is, okay, lower compared to the, at the center of the earth here, okay? right? So that's why there is different, because our earth is not a perfect sphere. Okay, so because so means they have a different. So let's say this one maybe, right? Maybe. Okay, let's say this one is 10. Okay, so this one must be more than 10. So let's say 12. So see, the distance here is higher. So that's why the gravitational force here is lower than at the North Pole. Okay. Okay, so this one before is not a perfect sphere. Okay, because the distance of the center of the earth is further, okay, compared to the poles. Okay, so the value of G is smaller at the equator than at the earth's pole. Okay, so for this one, if you can't copy, you can saw my video later to complete your notes. Okay. Alright, solving the problems. Okay. So before you know how to solve the problem, okay, this is actually the equation of motion that we already learned in chapter 2.1, right? Okay, but here, okay, the A here, we replace it with G. Okay, so all the acceleration here, we replace it with G. Okay, what is the value of G? 9.81. Okay, and then okay, you have to know one more thing. Okay, so G is always negative, whether the object is moved downward or upward. Okay, so let's say I have a ball. Okay, so if my ball move downward like this, okay, and you want to calculate whether velocity or initial velocity or the time or the displacement, okay, the G will be negative 9.81. Okay, right, so I will explain to you why. Okay, and then later, if let's say if you throw the ball upward like this, okay, the G will still be negative 9.81. Okay, 9.81. Okay, and then how about the S? Okay, so the S, okay, the displacement, if you throw your ball, okay, so this one we assume, right? We assume that when you throw the ball upward, okay, if you throw the ball upward, your S will be positive. Okay, but if you throw the ball downward, okay, your S should be negative, because you know displacement is a vector, right? So means they must include the direction, right? So upward is positive, downward is negative. Okay, now we back to the gravity. Teacher, why we throw upward, the G is negative? Okay, when you throw upward, okay, how about the velocity? Before this, your friend answered the velocity is decreased, right? Okay, so I said that one, the velocity is decreased when you throw your ball upward. Okay, so let's say you throw your ball upward. Okay, so when you throw your ball upward, it against the gravitational force, because the gravitational force going downward. Okay, you going downward, it's going downward, but you throw your ball upward. So means the ball have to overcome the gravitational force, right? So means the velocity will be decreased. Okay, velocity will be decreased because it has to oppose the gravitational force, right? So the V should be negative, should be decreased. So when V is negative, then V is decreased, right? So V is decreased is mean what? This one is deceleration. So remember deceleration, the aim is must be negative. When you calculate acceleration, if the A is negative, that's mean the object move with deceleration, right? So this one, that's why the G is negative. Because when you throw the ball upward, the velocity is decreased. So when velocity decrease, mean it's deceleration. So deceleration, the value of G must be negative. Teacher, can you repeat? I'm confused. All right. Okay, which part you are confused? The G part or the S part? The G part. Okay. For this one, for the S, you know why is positive, why is negative? Right? Okay, you know why this one is positive, this one is negative. Okay. So means only the G part problem. Okay. All right, so let's say I have a ball. Okay, so when you throw a ball, you can see the ball, the velocity of the ball is decreasing, right? The velocity of the ball decreasing. Okay, why is decreased? Okay, because actually the force should be like when you throw, when they say you let go the ball downwards, okay, it's same direction as the force, right? And so the same direction as the gravitational force. Okay, so let's say I draw here. Okay, let's say this is the ball. Okay, and I let go the ball move downward. Okay, and then at the same time, the force, the gravitational force also goes downward, and the ball also move downward. You can see there are two force that acting on the object. So the velocity is increasing. Alright, and then let's say if I throw the ball upward, okay, then the one force go upward and another force go downward. So what happened to the velocity? The velocity will decrease, right? So if you draw the graph, right, if you draw the graph, velocity against time, the velocity is decreased. So velocity decrease means what? Means deceleration. Okay, so deceleration, the A will become negative. The acceleration is negative, right, for the deceleration. So that's why the G here is negative. Can you understand? You want me to explain again? Anyone want me to explain again? Still confused? Are you clear now? Are you clear now why the G is negative? Okay, the G is negative because the velocity is decreased due to the gravitational force that acting in opposite way. Okay, so that is the G is negative. Okay, all right, what happened when the G is downward? Okay, so the G is still negative. Why? Okay, because of this one. The displacement for S is negative, right? It moved downward. So the S is negative. So when you use the A to find, if you want to use, you want to find A, you have to use V, right? So for if you want to use calculate V, you have to use S. So if your S is already negative, your V also should be negative, and your S also, your A also should be negative. Okay, so because we know A is V minus U divided by T, right? And then if you want to calculate V, V is S over T, right? So if you move downward, if the object move downward, the S is already negative here. So V also should be negative. Then when V negative, this one negative, A also should be negative. So that's why when you move upward and downward, your G is negative 9.81. Okay, so that one you have to very clear about this one. Okay, so this one you have to know because after this when you calculate you have to use this info. Okay, all right. Okay, let's try for exercise 1. So can you try first? If you cannot, then I will teach you. Okay, so this one I will give the formula in case you are still didn't remember. Okay, this is the first one, second one, this one, and another one is um, okay. So this is the four formula. Okay, so first take out the this one. Don't use 10. Okay, use 9.81. This one is a old syllabus. Okay, 9.81. Okay, so it already said falls from the height of 45 meter. So it moves downward, right? So the S is negative 45, right? Because it moves downward. Okay, the height here is negative 45 because it moved downward. Remember this one I told you already, right? It moved downward is negative. Okay, So here S is negative 45. Okay, and then they give you G is negative 9.81. Right, and then how long does it take to reach the ground? So asking you to find T here. Okay, so we assume before you release the rock, okay, the U is 0. Okay, so here I will replace A with T. Okay, which formula should I use? Number 1, number 2, number 3, or number 4? Got SUGT. Which one? Number 1. Yes, very good. So negative 45, right? I use number 1. Okay. S is U is 0. T is you need to find. Okay. Plus half. G is negative 9.81. Okay. And then this is T. Okay. So you can use your calculator here. Oh my god, yes. I cannot use my calculator here. Did you got the answer? This one, the T, no more, so left with negative 9.81 T. Okay, so what's your answer? Divide by 2, then 45. What's your answer? 40. Teacher. Until, yes, sorry. Oh, yeah. Right. So means 45, 9, negative 9.1 divided by 2, and then 45 divided by 3.029 seconds. Okay, correct. 3.029 or 3.03 seconds. Very good. Three point zero two eight nine one, something like that, right? So 3.03 second or 3.029. Teacher, how many the decimal point should we write to? You can write 2 or 3 decimal point. 2 or 3 decimal point. Okay. Okay, so let's move on. Okay. Oh, they ask you to find velocity. Okay. So velocity use V is equals to U plus AT. Okay, so U is 0. Okay, A is 9.81 and T is actually we already find here 3.03. Okay, so this one got mistake. Should be times 3.03. Okay, so we get 29.4 something. Okay, let's move on to this one. Okay, I may release a stone into a well, then if the distance between the top of the well and also the water surface is 20 meters. Okay, try to answer this one. Okay, so I write the formula here in case you still cannot remember. And then V is equal to U plus GT. And then another one is S is half plus U plus P T. Okay. And here, what is the info given? If the distance between the top of the well and the water surface is 20 meters. So mean the S is 20 meters. So it released the stone, mean S is negative, right? Because it moved downward like that. So S is negative. Okay, and then asking you to find the time. Okay, and then the G is negative 9.81. Okay, and then this one, the U is 0. So same, right? We use number 1 also, right? Okay. Right, so let's see. I call someone to answer this one. Teacher, so the G is always negative when there is a displacement. If no displacement, the G is negative as 9. Whether is no displacement or have a displacement, the G is still negative 9.1. Okay, the G will always be negative 9.1 because the object, whether it move downward or whether it move upward, okay, the G is still considered as negative 9.1 according to the reason that I already told you why the G is negative when it's going upward and why the G is negative when it's going downward. Okay. So it doesn't matter what's the condition, the G must be always negative 9.1. Actually, you don't need to know the reason, but I'm sure some of you wonder, right? Why the G is negative? So I explain for you the reason so maybe you can understand more. Okay, so actually G must be negative 9.1. Doesn't matter what is the condition, whether the upward or downward, right? Then the formula V is used plus GT. Yes, yes, yes. So it should be like this actually, right? U minus GT like that. Okay. But I just put like this because I don't want you like to be confused, right? Because in the linear motion we learn, right? In the linear motion we learn this one as S is UT plus half AT square, right? So I don't want later when you use the linear motion, so maybe you confuse, you put here negative. So I just put all this positive, but later when you put G is negative, it will change, right? It will change. So for me, it's better for you to memorize this one. So mean for the and then the G negative, it doesn't matter. When you put the negative, the sign will be combined like that. Positive, negative become negative. Okay. Okay, so can I call anyone? Are you finished? Let's try um, Ng Ki Hao. Ng Ki Hao. Ng Ki Hao. Are you here? Ng Ki Hao? Ng Ki Hao, are you here? You can open your mic, you can type in the chat. Ng Ki Hao. I call once again. Ng Ki Hao 1, Ng Ki Hao 2, Ng Ki Hao 3. Okay, no. Okay, so I will move on. Ng Ki Hao is from 4M, right? Okay, so make it absence. If you don't reply me, I will just consider you as absent. Okay, so let's go to the Ku Jia Yao. Is it correct? Ku Jia Yu, sorry. Ku Jia Yu. Are you here, Ku Jia Yu? Yes, right. So what's the answer for this one? For A, T is 2.02. Okay, so let's see whether it's correct or not. So I use number 1, right? So S is negative 20, U is 0, T you need to find half, sorry, half negative 9.81. Okay, and then this one is T squared. Okay, so negative 20 Okay, so this one should be 9.81 divided by 2. Okay, and then negative 20, negative 20, 9.81 divided by 2, negative 20 divide answer, answer, okay, 2.02, correct. Okay, so this one should be half negative 9.81 t square, right? So I got t is equals to 2.02 second. Did all of you got 2.02 second? Any other answer than 2.02 second? Yeah, very good. Okay, 2.02 second. Okay, so this is the last question. Okay, and then after that, for the rest, I want you to try, and I will make a video for you to check your answer. You can check your answer there. Okay, for number 3, Amira threw a ball vertically upwards, okay, with an initial velocity of 10 ms negative 1. So you have to calculate the time for the ball to achieve a maximum height. Okay, all right. So, and then B, maximum height that can be reached by the ball, and then you have to ignore the air resistance. Okay, so this one, the move upward mean the S is, sorry, the wall. Oh yeah, yeah, yeah. The velocity is not yet count. I always skip that part. Okay, for this one, it's same like the first one. Okay, we use the V is equals to U plus AT. Right, U is 0. Okay, A is 9.81. Okay, T is 2. Actually, you have to use 2.02. Okay, don't put 2 here. 2.02. Okay, and then you just multiply. You got 90.6 M over S. Right? Sorry. Okay, so we move on to the next one. Okay, so this one move upward, S is positive. Okay, so the S is positive. Okay, so we don't know the S here. Okay, but we know the S is a positive value. Okay, and then the next part is initial velocity is 10. So U is 10 ms negative 1. Okay, and then asking you to find the time for the ball to achieve the maximum height. So T, you need to find T here. Okay, alright, so the G is negative 9.81. Okay, so any idea what formula we should use? This one is S is UT plus half GT square. Okay, and then this one is V square U square plus 2GT, and then the third one is V is U plus GT, and then the last one is S is half U plus V times T. Okay, any idea how you want to get T? Which formula that we should use? We only got U and G only. We don't have S, we don't have T. Use 2 to get the T. V. We don't have V. So how we want to get V? Yes, very good, Isaac, right? So V is 0. Okay. So when you pull, let's say you throw your ball upwards, right? Okay, and then you know that it will go downward like that. Okay. So when you reach at the maximum here, maximum height here, the V is equals to 0. The ball will stop a moment. It's not like very long, it's very, very short. Okay. The V will stop, okay, at certain time, at a certain height, okay, at the very highest, okay, highest part, okay, it will stop. Okay, it will stop a moment and then it will go down again. Okay, very good, I said. Okay, so when you have to know when you reach the maximum height, the V is 0. Okay, the V is 0. Okay, very good. Okay, now we already have V, we already have U, we already have G, we already have T. So which formula that we can use to find T? We can use number 2, right? Because we already have V here. Okay, we already have V here, and also we already have U, and we already have G. So we can find T. Okay, so we use number 2 here. Okay, so V is 0. Okay, V is 0. U is 10 power of 2 plus 2 negative 9.81. Okay, and T you need to find. Okay, so this one should be negative 100 because I move to the other side. Okay, so 9.81. Okay, 9.81 times 2. You got negative 19.62. Teacher, the third formula is easier. Yeah. B, U, G, and T. Yeah, also can. But I already used number 2. Okay, yeah, you can use number 3 also. For those of you, you can use number 3 also and see whether we can get the same answer if you use number 3. Okay, all right. Okay, so negative 100 divided by negative 19.62. So you get 5.1, I think. Did you get 5.1? Yeah, because if I got 5.096, right? So if I round off to 2 decimal point, I will get like 5.1. Or you take 3. Okay, if you take 3, then you can get 5.097. Okay, if you take 3, you can get 5.97. Or if I take 1 also, 5.1. Or because if I take 2, it will be like 5.10 like that, right? So we don't need to put 0 there. Okay, or you can put 5.097 also can. I said, do you use the equation number 3? Did you get the same answer like me? Or any other of you use equation number 3? Did you get the same answer like me? Same. Alright, very good. Okay, for B, maximum height that can reach by the ball. So now we already need to find the S. What is the maximum height? Okay, so V is 0, U is 10, okay, G is negative 9.81. Okay, so which one you want to use? I think I use 2as. Which one is v square u square plus 2as? I think I use this one. I think I use this one, number 4, right? Number 4. Because this one is a lot easier. This one got square, right? So we use number 4. Yeah, 1, 4 also can. But this one, they got square here, right? So I think I will use number 4. Okay. So S is half, U plus V is 10 plus 0. Okay, and then the time we already count before is 5.1, or I put 5.1, you can use 5.097 also. Okay, so get the answer here. So 1 over 2 times 5 times 5. I got 12 point. Did you divide first? U plus V plus T. 25.5. Wait. Oh yeah. 25.5. Yes. 25.5 meter. Good. Okay. So any other question you want to ask? For free fall. So what we learned today, free fall. Free fall is fall under the gravitational force only. It does not influence by the mass. It's influenced only by the surface of the area. Okay. And then when it's in vacuum, right, the object will reach at the same time because there is no air resistance. Okay. And then you have to know the movement. Okay. The G will be negative. Okay. Whether it move upward or move downward. And I already explained the reason why. And the S, okay, the displacement is positive when you move upward. and it's negative when it moves downward. Teacher, just now for A, can do the same answer using formula 3. Means you cannot get the same answer if you use a formula 3, is it? Okay, let's try. V is U plus GT. The answer become 1.02. Wait. V is 0, U is 10, G is negative 9.81, right? And then T you need to find 10 negative 9.81 T. So negative 10 divided by negative 9.81. 1.02. V is U plus 80. Teacher, I think the formula 2 is wrong already. The T should be in formula. The T should be S in formula 2. Wait. Yeah. That's what I'm thinking. Ah. Yes. This one should be V square U square plus 2AS, right? So this one should be V U square plus 2GS, right? Okay, so let's try for number A means I use this one, right? So mean you use number, the answer should be 1.02. Okay, so wait, I calculate again. Wait. Yeah, the answer is 1.02. Control A. Okay, so we use this formula, right? 2GS. Okay, so V we got like, what is the V here? The V here is 0, U is 10. Okay, V is 0, U is 10, G is negative 9.81. Okay, so you need to find S. Okay, so negative 100, and then this one should be negative, wait, I calculate first. Negative 19.62. Is it correct? Correct answer. I still get 5.09. Wait. Okay, let's erase all this. Okay, we do it again. This is the height. Okay, we do it again. Okay, so let's say U, that's why I don't like to use. I replace, then when I replace, it become wrong. Just use this one. Okay, then later A, I will replace with G. Yeah, this one is much better. Another one is this one. No. S is half plus U plus V times T. Okay, right. So let's say for 3A, okay, they give you, okay, G we already know negative 9.81. Okay, and then we already know U is 10. Okay, V is 0. Okay, and then time you need to find. Okay, so this one VUAT. Right, VUAT, so we can use this one. Right, V plus U plus A plus AT. Okay, so V is 0. Okay, I use number 3. Okay, so V is 0, U is 10. Okay, plus G I replace with negative 9.81. Okay, T I need to find. Okay, so I just change here, so negative 9.81 T. Right, so T is, yeah, this one. is 9.81. Okay, so this one I get 1.02 second. Yes. Okay. So that's why I don't like to change A with G. So that's the reason. Okay, later we be confused. Okay, so are you clear for 3A? Anyone still confused? I'm sorry. Anyone are clear for question number 3A? Right, very good. Okay, for B, you need to find the maximum height. So mean you have to find the S here. Okay, we already got G. We got U here, we got V here, and we got T here, 1.02. So this one, which one you should use? Got S, right? I think I use this one, number 4. Okay, so S is half, U is 10, V is 0, T is 1.02. So what's the answer? 1 over 2 times 10 times 1.02. 5.1, right? Did you got 5.1? Is it same? Yes, okay. So 5.1 meter. Okay, so that's the answer for B. Okay, so means you're already good. Right, very good. Okay, so the next one, you have to do on your own. Okay, so I will give the answer in the I will make a video that I will upload in YouTube. You can check your answer there with the tutorial. Okay, and then for the next week, right? Next week I will not be able to teach you. Okay, so until Tuesday and Wednesday, because I have to mark the SPM paper. So I have a meeting. Okay, so I will ask Mr. Jim to take over my class. Okay, so but I will do an extra class. Okay, so you don't need to worry. I will do the extra class for you. Okay, I will tell you the time and the day. Okay, later. Right. So if anything, you can text me. Okay, so take care. Right, thank you. And please, I already assigned the quiz for you online for the free form. Okay, so please answer okay, at the Google Classroom. Okay, so I stop until here. Okay, take care. Okay, see you later. Bye.
Thank you, teacher. Bye, teacher.
Bye.
Thank you, teacher.
Thank you, teacher.
Bye. Welcome.